Welcome to the Dream Architect channel. Today, we'll journey into the strangest and most unexplainable corners of the universe, places where the laws of physics seem to pause in awe. We'll touch the silence of vast cosmic voids where not a single star burns. We'll listen to mysterious signals drifting from the depths of time. We'll gaze into the eyes of stars that shouldn't exist and approach the edge of the event horizon itself, where reality breaks apart into pure information. This is not just a list of anomalies. It is a meditation on the infinite mystery of being, a lullaby woven from questions that still have no answers. If you enjoy these quiet journeys, I invite you to like, subscribe, or share your thoughts below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy and your mind soften. Let's begin. Imagine a place in space so empty and so immense that even the word emptiness feels too small to describe it. This is the Great Void in the constellation of Boötes, a colossal spherical region almost 330 million light-years wide, nearly devoid of galaxies. If our Milky Way were placed at its center, we wouldn't have discovered other galaxies until the 1960s. Such is its cosmic isolation. It is a silent desert where light travels for hundreds of millions of years, meeting almost nothing along the way. Some theories suggest it was born from the merging of smaller voids, yet its enormous scale still challenges our understanding of the universe's structure. It feels like a deep, soundless exhale of the cosmos, a reminder that creation is made not only of light, but also of vast, enveloping nothingness. Yet even in our corner of the cosmos, this great nothing lies closer than it seems. Our own galaxy sits at the edge of another, lesser known but equally impressive emptiness, the local void. It's as if we live on the shore of a giant, invisible ocean of nothingness, stretching 200 million light-years across. This proximity helps explain why the Milky Way and our neighbors in the local group are moving unusually fast toward the Virgo constellation. We are not only pulled by distant clusters, we are also pushed by this vast region of low-density space. We drift through the cosmos, carried by a ghostly wind blowing from a quiet vacuum right beyond our doorstep. And from this great nothing, we turn to one of the largest known structures in the universe, a colossal wall woven from galaxies themselves. The Hercules Corona Borealis Great Wall is an immense web of galactic filaments and superclusters stretching an unbelievable 10 billion light-years across. That's so large that light would take nearly the entire age of the universe to cross it. According to modern cosmology, the universe should appear uniform on such scales, but this structure breaks that rule. It is far too massive to have formed in just 13.8 billion years. This wall of light and gravity stands as a silent challenge to our models, a quiet hint that we may be seeing only a fraction of the true cosmic design. This architecture of the cosmos is filled not only with walls, but with invisible centers of attraction that distort the very motion of space itself. Meet the Great Attractor, a gravitational anomaly hidden in intergalactic space that pulls our Milky Way and hundreds of thousands of other galaxies toward it at millions of kilometers per hour. We cannot see it directly, for it lies behind the dense plane of our own galaxy, a region known as the zone of avoidance. It's like trying to glimpse something hidden behind a blinding spotlight. We can feel its pull. We can see whole clusters of galaxies flowing toward it like rivers into an unseen ocean. And yet, its true nature remains a mystery. Perhaps it is a massive cluster of galaxies, or perhaps something else entirely, concealed behind the Milky Way's veil of dust. That veil of starlit dust, hiding entire regions of the cosmos from us, is itself part of the illusion. The zone of avoidance is not a physical barrier, but rather a curtain created by our own galaxy. Thick clouds of gas, dust, and countless stars in the Milky Way block the light of more distant objects, making about 20% of the night sky practically invisible to optical telescopes. Astronomers of the past named it that way because they avoided observing there. The region seemed almost empty of galaxies. Today, using infrared and radio telescopes, We are learning to peer through this curtain and reveal the hidden clusters and anomalies beyond it. It's a reminder that our view of the universe is always limited, shaped by the perspective of our own stellar home. Even in the places where nothing blocks our view, we still see only a small fraction of what truly exists. All visible matter, the stars, planets, and galaxies, makes up less than 5% of the universe's total mass and energy. The remaining 95% is a mystery, divided into two even more enigmatic substances. About 27% is dark matter, the invisible gravitational glue that keeps galaxies from flying apart. It neither emits, absorbs, nor reflects light, revealing itself only through its pull. We know it's there because we can see how stars on the outer edges of galaxies move far too fast, as if held by an unseen hand. It is the silent skeleton of the cosmos, the invisible framework that holds together everything magnificent we can see. If dark matter is the hidden glue that binds the universe, then dark energy is the mysterious force that tears it apart. It accounts for about 68% of all energy in existence, and it is responsible for the accelerated expansion of the universe. Instead of slowing down under gravity, as one might expect, galaxies are flying away from each other faster and faster. Dark energy is like a form of anti-gravity woven into the very fabric of space-time itself. It's a quiet but relentless breath that inflates reality, pushing galaxies beyond the horizon of what we can ever observe. Its nature is one of the greatest mysteries of modern physics, and its ultimate effect may determine the fate of everything, dissolving the cosmos into endless, silent isolation. We know what the universe is made of, yet when we try to count it, much of the ordinary matter simply disappears. This is known as the missing baryon problem. The Big Bang Theory and the cosmic microwave background precisely predict how many protons and neutrons, that is, ordinary baryonic matter, should exist. But when we add up all the matter in stars, gas, and dust within galaxies, we find only about half of that total. So where is the rest? Recent discoveries suggest it hides in the form of extremely hot, diffuse gas filling the filaments of the cosmic web, the immense network connecting galaxies. This invisible matter is too hot to glow and too thin to detect directly, forming a warm mist that shrouds the skeleton of creation. In search of the elusive dark matter, scientists descend deep underground, into abandoned mines and mountain tunnels. There, in perfect silence and darkness, far from cosmic rays and noise, stand the most sensitive detectors in the world, like Xenon 1T and Lux. These experiments use giant tanks filled with ultra-pure liquid xenon, surrounded by thousands of light sensors. The idea is simple. If a dark matter particle, known as a WIMP, happens to collide with a xenon atom, it would create a tiny flash of light, just enough for the detectors to capture. Years of waiting in total stillness have yet to bring results, but each day, these underground observatories keep listening to the silence of matter, hoping to catch a whisper from the invisible universe. Sometimes this hidden universe reveals itself in the most unexpected ways, by creating cosmic mirages. Gravitational lensing, first predicted by Einstein, occurs when a massive object, such as a galaxy cluster, bends space-time around it. Light from more distant objects passing near this lens becomes distorted and magnified, forming graceful arcs, glowing rings, or even multiple images of the same object. Sometimes we see a galaxy as it looked at different moments in time because its light reached us along different paths. This allows us to peer into the early universe, using galaxies as natural telescopes. Here, gravity acts not as a force, but as an artist, painting with light upon the canvas of space. One of the most beautiful examples of this cosmic art is the Einstein Cross. In the constellation, Pegasus lies a quasar, 8 billion light-years away. But between us and that quasar, about 400 million light-years from Earth, sits a massive galaxy. Its gravity acts as a perfect lens, splitting the quasar's light into 4 distinct images arranged around the galaxy's center in the shape of a cross. We see not one, but 4 versions of the same object, 4 echoes of the same ancient light, reaching us along slightly different routes through warped space-time. It's living proof that reality is not as straightforward as it seems, and that gravity can create true masterpieces of celestial geometry. From the geometry of light, we move to the geometry of galaxies themselves, shapes that sometimes defy all explanation. Hoag's object is one of the strangest galaxies known to science. It's an almost perfect ring of young blue stars surrounding a dense core of old yellow ones, with an empty gap between them. It has no spiral arms, no bar, no visible structure connecting its heart and ring. How it formed remains a complete mystery. Perhaps it's the result of a galactic collision, but there's no trace of one. It hangs in space like a golden eye with a blue iris, a quiet reminder that even on the scale of galaxies, nature loves to craft unique and unrepeatable masterpieces. Not all galaxies are so calm and solitary. Some behave like predators in the cosmic jungle. Galactic cannibalism is the process by which a large galaxy devours a smaller neighbor. The giant's gravity rips the dwarf galaxy apart, creating long, shining streams of stars that eventually merge with the predator's body. Our own Milky Way is doing this right now, consuming several dwarf galaxies, including the one in Sagittarius. These stellar streams, ghostly rivers flowing through our galactic halo, are living evidence of its turbulent past and continuing growth. Each stream is an epitaph for an entire stellar world, absorbed into something greater. Sometimes the traces of this cosmic cannibalism appear not as rivers, but as thin, glowing tendrils. Jellyfish galaxies are one of the most astonishing sights in the universe. When such a galaxy speeds through the hot gas of a dense cluster, that gas acts like a headwind, stripping away its own gas and stretching it into long, trailing tentacles. Within those filaments, far from the parent galaxy, new stars ignite, creating the illusion of a glowing jellyfish drifting through the dark sea of space. It's a striking example of how even the emptiness between galaxies can shape their fate, painting their agony in the light of newborn stars. In this cosmic ballet of collisions and mergers, true giants are born, like the El Gordo cluster. It is the most massive galaxy cluster observed in the early universe, the result of a colossal collision between two enormous clusters smashing into each other at millions of kilometers per hour. Its hot gas glows brightly in X-rays, and its total mass is 3 quadrillion times that of the Sun. El Gordo, Spanish for the Fat One, is a cosmic catastrophe of unimaginable scale, a natural laboratory for studying how the largest structures in the universe are born, forged in fire and gravitational chaos. But what if a galaxy were made almost entirely of empty space and invisible matter? There may exist dark galaxies, hypothetical objects composed mostly of dark matter, with very few stars or gas. They are nearly impossible to see because they emit almost no light. One such candidate, Dragonfly 44, has a mass comparable to the Milky Way, but with 100 times fewer stars. It's almost transparent. How such galaxies form, and why they have so few stars, remains a mystery. They may be the missing link in our understanding of galactic evolution, ghostly islands adrift in the cosmic ocean that we're only beginning to glimpse. Sometimes the mystery lies not in an excess of dark matter, but in its absence. A globular star cluster called Pandas 48, located in the Andromeda Galaxy, appears to be almost completely devoid of dark matter, even though theory predicts that such small systems should be dominated by it. This defies the standard model of galaxy formation. How this cluster manages to stay bound without the gravitational glue of dark matter, or how it might have lost it, remains unknown. This anomaly, along with dark galaxies that contain too much dark matter, poses serious challenges for our cosmological models. The universe, it seems, refuses to follow a single rule for all its creations. Another challenge is what astronomers call the too-big-to-fail problem. Computer simulations of galaxy formation, based on cold dark matter theory, predict that large galaxies like the Milky Way should have many more massive satellite galaxies than we actually see. Instead of dozens of big companions, we observe only a few, while the rest are much smaller dwarfs. Where did the missing giants go? Perhaps our simulations are wrong. Or maybe processes like stellar winds have suppressed star formation in these satellites, leaving them faint and hard to detect. It's a quiet rebellion of reality against our digital universes. From ghostly islands of matter, let us turn to ghostly sounds echoing from the depths of space. On August 15, 1977, the radio telescope Big Ear picked up a powerful, narrow-band signal lasting 72 seconds. It was so strong and unusual that astronomer Jerry Eman, reviewing the data printout, circled it and wrote in the margin, "Wow." The signal came from the direction of the constellation Sagittarius, and its frequency was strikingly close to that of hydrogen emission, making it a perfect candidate for an artificial origin. Despite countless follow-up searches, it was never detected again. It remains a one-time, unexplained anomaly, the most famous call from the cosmos that humanity has never been able to answer. That lonely call was later joined by an entire chorus of cosmic voices. Fast radio bursts, or FRBs, are extremely powerful yet incredibly brief flashes of radio energy from distant galaxies. In just a few thousandths of a second, one burst can release as much energy as the sun emits in several days. Some of them repeat, allowing scientists to trace their origins. But the true nature of these sources remains uncertain. The leading candidates are magnetars, neutron stars with unimaginably strong magnetic fields. Yet the variety of signals hints that there may be more than one cause. Each burst is like a lightning strike in the stillness of the cosmic night, brief, brilliant, and breathtaking. If FRBs are the screams of the universe, then pulsars are its steady heartbeat. A pulsar is a rapidly spinning neutron star left behind after a supernova explosion. It has an incredibly strong magnetic field that channels beams of radio waves from its magnetic poles. Because the magnetic and rotational axes don't align, these beams sweep across the sky like the beam of a lighthouse. When Earth happens to pass through that beam, we detect perfectly timed pulses. The first discovered pulsar had such precise regularity that astronomers jokingly called it LGM-1, short for Little Green Men 1. Pulsars are the most accurate clocks in the cosmos, ticking faithfully for millions of years. But some of these clocks behave in very strange ways. There are pulsars that suddenly switch off for minutes, months, or even years, and then turn back on just as suddenly. This phenomenon is known as intermittent pulsation. During the off phase, the radio emission almost completely disappears. The exact mechanism behind this switch remains unclear. It may be caused by changes in the neutron star's magnetosphere, streams of plasma that alternately block or reopen the path for radio beams. Such objects are like cosmic lighthouses with flickering lamps, fading into darkness only to flare again with their rhythmic but temperamental light. In 2017, our solar system was visited by something unlike anything we'd ever seen before. It was named Oumuamua, a Hawaiian word meaning scout or messenger. It was the first confirmed interstellar object ever detected. It had a strange, elongated shape, like a cigar, and moved with a small but unexplained acceleration, as if something were gently pushing it. It showed no cometary tail, ruling out the usual explanation of evaporating ice. Its path and behavior were so unusual that some scientists suggested it might be artificial, perhaps an alien probe or a solar sail. After passing near the sun, it left our system forever, carrying its secret into the interstellar dark and leaving us to wonder, was it merely a peculiar rock or the first greeting from another cradle of stars? Even stranger are the stars that seem to defy the rules of stellar evolution. Blue stragglers are stars found in ancient globular clusters that look much younger and hotter than their neighbors. While most stars in such clusters are old, red giants, these stragglers shine brightly in blue. They're like retirees who somehow look like teenagers. The most likely explanation is that they form when two old stars merge, or when one star vampirically steals matter from its companion, rejuvenating itself in the process. These stars are vivid reminders that even in the oldest, quietest corners of the universe, life and light can flare up anew with unexpected brilliance. That power can take even more extreme forms. Magnetars are a rare and most dangerous kind of neutron star, possessing magnetic fields a quadrillion times stronger than Earth's. So powerful, in fact, that a magnetar halfway to the moon could erase every credit card on Earth. These magnetic fields are unstable, sometimes causing starquakes on the surface that unleash titanic bursts of gamma and X-rays. One such burst in 2004 was so intense that, even from 50,000 light-years away, it ionized Earth's upper atmosphere. Magnetars are true magnetic monsters, sleeping giants scattered through the depths of the Milky Way. From magnetic monsters, we turn to stars that, by all logic, shouldn't exist at all. The Thorne-Zhitkov object is a hypothetical type of star, a red giant or supergiant with a neutron star hidden in its core instead of a normal fusion center. Essentially, it's a neutron star wrapped in a swollen envelope of stellar gas, a fusion of opposites. The quiet death of one star merged with the fiery life of another. Such an object could form when two stars in a close binary system collide and merge. It would appear as an unusually bright red supergiant with a strange chemical fingerprint. A few candidates have been found, but none confirmed. They are centaur stars, hybrids of two cosmic worlds, born from calm extinction and violent rebirth. Some stars astonish not by their structure, but by their behavior. Tabby's star, or KIC 8462852, became famous for its inexplicable irregular dimming, sometimes by as much as 22% of its brightness. No known planetary transit or stellar process can explain such deep and chaotic fluctuations. One of the most intriguing, though unlikely, ideas is that the star may be partially surrounded by a Dyson sphere, a massive structure built by an advanced civilization to collect its energy. More mundane explanations include a swarm of comets or a dense dust cloud. Yet Tabby's star remains the most mysterious star in the galaxy, its flickering light a question written in the language of photons that we still cannot read. Starlight doesn't only flicker, it also carries stories from billions of years ago. Gamma-ray bursts are the most powerful explosions in the universe since the Big Bang. They last from fractions of a second to several minutes, releasing more energy than the sun will emit in its entire lifetime. Short bursts are likely caused by merging neutron stars, while longer ones mark the collapse of massive stars into black holes. These cataclysms are so bright they can be seen from across the visible universe. Each gamma-ray burst is the dying scream of a star, or the violent dance of two collapsing titans, echoing across the abyss of time. Sometimes, those cosmic screams bring with them particles of impossible energy. In 1991, scientists detected a cosmic ray with an energy of 320 exa-electron volts, nicknamed the "Oh my God" particle. Its energy was so immense that, if it were a baseball, it would have been flying at 100 kilometers per hour. According to physics, such high-energy particles should quickly lose energy when colliding with the cosmic microwave background, meaning their source must be nearby, within 160 million light-years. But within that range, there is no known object capable of accelerating a particle to such a speed. This ghostly visitor seemed to come from nowhere, shattering our understanding of high-energy physics. The limits of our knowledge are constantly tested, especially as we approach the most extreme objects in existence, black holes. These are regions of space-time where gravity is so strong that nothing, not even light, can escape. The boundary beyond which escape is impossible is called the event horizon, not a physical surface, but a point of no return. To a distant observer, anything falling in appears to slow down endlessly at the edge, while for the falling object, the crossing happens in an instant. Black holes are scars in the fabric of reality, places where the known laws of physics collapse, leaving only pure gravitation. At the center of every black hole lies what Einstein's theory predicts: a singularity, a point of infinite density and zero volume, where space-time curvature becomes infinite. Yet most physicists believe this is a sign that our theories break down. Quantum mechanics must come into play at such scales, but we still lack a complete theory of quantum gravity to describe what really happens there. Perhaps there is no true infinity at all. Perhaps there's something unimaginable instead, a Planck star, or even a bridge to another universe. A singularity is the place where mathematics itself screams in pain, begging for new physics. Despite their name, black holes aren't entirely black. Stephen Hawking predicted that quantum effects near the event horizon should cause black holes to emit faint radiation, now known as Hawking radiation. Through this process, a black hole slowly loses mass and eventually evaporates. The smaller it is, the faster it disappears. Microscopic black holes, if they exist, would vanish in an instant with a burst of energy, while stellar mass ones would take unimaginable time spans to fade away. Hawking radiation is the quiet whisper by which a black hole repays its debt to the universe, dissolving gently into the void over eons. But this whisper carries one of the deepest puzzles in physics, the information paradox. According to quantum mechanics, information cannot be destroyed. Yet if something falls into a black hole and the hole later evaporates through featureless Hawking radiation, where does that information go? Is it erased from the universe, breaking the fundamental rules, or somehow encoded in the radiation that escapes? Perhaps it's stored on the event horizon itself, written in a holographic pattern. This paradox sits at the crossroads of gravity and quantum theory, and solving it may transform our understanding of reality itself. And if black holes exist, devouring everything, could their opposites exist as well? White holes are purely theoretical objects, mathematical twins of black holes that behave in reverse. Nothing can enter them from the outside. Matter and light can only emerge. No one can cross their event horizon inward. Some theories suggest that white holes might be connected to black holes through wormholes, or that the Big Bang itself was a kind of white hole. So far, there is no observational evidence they exist. They remain elegant, ghost-like symmetries, haunting the equations of physics. The symmetry of Einstein's equations also gives rise to the idea of wormholes, or Einstein-Rosen bridges. These are hypothetical tunnels through space-time that could, in theory, connect two distant points in the universe, or even two entirely different universes. Imagine folding a sheet of paper, representing space, and piercing it with a pencil. That's the shortcut a wormhole would provide. However, according to general relativity, such tunnels are inherently unstable and would collapse faster than anything could pass through them. To keep them open, one would need exotic matter with negative energy density, something that may not exist at all. For now, wormholes remain the realm of theoretical physics and science fiction, but they continue to stir the imagination as a tantalizing mathematical possibility. As we ponder journeys through space, we can't help noticing that space itself sometimes behaves strangely. The Pioneer anomaly is one such example, a deviation observed in the trajectories of the Pioneer 10 and Pioneer 11 spacecraft. They appeared to be slowing down slightly more than calculations predicted, as if a faint, unknown force were gently tugging them toward the sun. For decades, scientists puzzled over the mystery, even proposing new physics to explain it. Eventually, the most likely cause turned out to be something far more ordinary: anisotropic thermal radiation emitted by the spacecraft themselves. Their radioisotope generators heated one side more than the other, and the recoil from those heat photons produced a minuscule drag. It was a subtle reminder that sometimes the simplest explanation really is the right one. Not all anomalies in motion are so easily explained. The flyby anomaly refers to mysterious changes in the speed of spacecraft as they perform gravitational assists around Earth. When approaching the planet, some probes gain a small but measurable boost in velocity, one that cannot be accounted for by known gravitational or atmospheric effects. It has been observed in several missions, including Galileo and Rosetta, but not in others. The magnitude of the effect seems to depend on the geometry of the flyby, yet no consistent rule has been found. This tiny but persistent puzzle might point to a gap in our understanding of gravity, or to some subtle, undiscovered effect linked to Earth's rotation. The rotation of massive bodies truly does influence space-time, another of Einstein's remarkable predictions. The lens-Thirring effect, or frame dragging, describes how a rotating object, such as Earth, literally twists space-time around it, much like a spinning sphere stirring honey. This phenomenon was confirmed by NASA's Gravity Probe B satellite, which carried ultra-precise gyroscopes in polar orbit. Over a year of flight, the axes of those gyroscopes shifted by exactly the tiny amount predicted by theory. Gravity, it turns out, does more than pull. It drags the fabric of reality itself, like a slow, silent whirlpool in the cosmic sea. The fabric of reality doesn't just twist, it also vibrates. Gravitational waves are ripples in space-time caused by the most violent events in the universe, such as the collision of black holes or neutron stars. They travel at the speed of light, stretching and squeezing everything in their path. For decades, they were purely theoretical, until 2015, when the LIGO Observatory made the first direct detection of waves from a merging pair of black holes. That discovery opened a new era of astronomy, gravitational wave astronomy. Now we can not only see the universe, but also hear it, capturing the vibrations of space-time itself, the echoes of cosmic cataclysms. Sometimes those vibrations come from sources no one expected. At the center of our own Milky Way lies a supermassive black hole called Sagittarius A. Around it, surprisingly close, orbits a cluster of young, massive stars. According to theory, stars shouldn't be able to form in such an extreme gravitational environment. So how did they get there? One idea suggests they formed elsewhere and migrated inward. Another proposes they were born from the accretion disk surrounding the black hole itself. This paradox of youth at the galaxy's heart challenges our understanding of how stars form. A quiet reminder that even the core of our home galaxy holds secrets we don't yet grasp. The heart of the Milky Way hides even more mysteries. Astronomers recently discovered enormous structures rising from its center, the Fermi bubbles. They are two gigantic lobes filled with hot gas and high-energy particles, glowing in gamma rays. These bubbles stretch 25,000 light-years above and below the galactic plane. Their origin is uncertain, perhaps the aftermath of a violent outburst from Sagittarius A millions of years ago, when it devoured a massive object. These ghostly bubbles stand as silent witnesses to an ancient storm that once raged in the center of our stellar home. But how did such cosmic engines, the supermassive black holes, grow so quickly in the first place? Observations show that quasars hosting billion solar mass black holes already existed when the universe was less than 1 billion years old. Far too soon for a small black hole to grow that large through ordinary accretion. This growth paradox forces astronomers to rethink early cosmic history. Perhaps these giants formed through the direct collapse of enormous gas clouds, skipping the stellar phase entirely, or through the rapid merging of smaller black holes. The early universe, it seems, had a way of building monsters in record time, defying our notions of gradual cosmic evolution. Evidence of this puzzle can be seen in discoveries like Galaxy HD1, one of the most distant ever found. We observe it as it appeared only 330 million years after the Big Bang. It shines intensely in ultraviolet light, suggesting either extreme star formation or the presence of a large black hole already in its core. If the latter is true, HD1 would be the earliest known quasar, pushing the question of how such massive objects formed to an even sharper edge. This distant galaxy is a window into the infancy of the cosmos, and what we see there compels us to rewrite its opening chapters. Asymmetry reigns not only in time, but in space as well. The so-called axis of evil is a provocative term for an unexpected pattern found in the cosmic microwave background, the ancient afterglow of the Big Bang. This radiation should be nearly uniform in all directions, but detailed maps show a strange alignment in its largest temperature fluctuations. Even more curiously, this axis seems almost aligned with the plane of our solar system. It could be an enormous coincidence, or a hint of new, unknown physics that shaped the early universe and left its fingerprint on the first light. Another mystery hidden in that primordial glow is the cold spot, a vast, unusually cold region in the cosmic microwave background. The odds of such a feature arising by chance are incredibly small. One idea attributes it to a massive supervoid lying between us and the ancient radiation. More speculative theories suggest it might even be the bruise left by a collision between our universe and another long ago. The cold spot remains an open window into the grandest and strangest processes of cosmic dawn, its nature still waiting to be revealed. The leading suspect behind the cold spot is the Eridanus supervoid, a colossal region of space nearly empty of galaxies, stretching 500 million to 1 billion light-years across. It happens to lie in the very direction of the cold spot. According to the Sachs-Wolf effect, photons of the cosmic background lose a bit of energy when passing through such a vast void, since there's less gravity to pull them back on their way out. While the size of the Eridanus supervoid may not fully explain the phenomenon, it remains the prime candidate, a cosmic lens that chilled the ancient light on its long journey to us. The problems with our understanding of the early universe don't end there. The so-called cosmological lithium problem lies in the fact that the observed amount of lithium-7 in the universe is about 3 times lower than predicted by the Big Bang theory. Calculations of primordial nucleosynthesis, which accurately predict the abundance of hydrogen and helium, fail when it comes to lithium. So where did the missing lithium go? Perhaps it was destroyed inside stars more efficiently than we think. Or perhaps our models of the early universe contain a fundamental flaw. This tiny, stubborn element challenges our understanding of the very birth of matter itself. The birth of matter might not have been the only event at the dawn of time. The theory of cosmic inflation proposes that in the first fraction of a second after the Big Bang, the universe expanded exponentially, smoothing out all irregularities. This theory elegantly explains many observed features of the cosmos, but it also predicts something extraordinary: eternal inflation. In some regions, this expansion may never stop, giving rise to an infinite number of bubble universes, each with its own physical laws. Our universe could be just one bubble in a vast boiling foam of the multiverse, a breathtaking but so far entirely untestable idea. Within our own cosmic bubble, there may still exist traces of exotic origins. Cosmic strings are hypothetical one-dimensional defects in space-time, thought to have formed during phase transitions in the early universe. They would be thinner than an atom but unimaginably dense and tense, bending space around them. If such a string passed through a star, it could produce multiple images of that star due to gravitational lensing. They should also be powerful sources of gravitational waves. No direct evidence has yet been found, but they remain an intriguing possibility. Relic threads from the first moments of existence, woven into the very fabric of reality. Even stranger forms of matter might exist, such as strangelets, tiny droplets of strange matter. According to one hypothesis, under extreme pressures, for example inside neutron star cores, ordinary protons and neutrons could break down into their fundamental components, quarks. If a stable combination of up, down, and strange quarks formed, it might create a new type of matter entirely. In theory, a droplet of such matter would be perfectly stable, and if it touched normal matter, it could catalytically transform it into strange matter as well. That would make any stray strangelet drifting through space potentially catastrophic. Fortunately, their existence remains purely theoretical, a ghost from the depths of nuclear physics. Theory also predicts the existence of magnetic monopoles, particles that possess only one magnetic pole, north or south, instead of the usual paired poles. Many grand unified theories suggest that vast numbers of monopoles should have been produced in the early universe. Yet despite decades of searching, none have ever been found. This monopole paradox was one of the main motivations behind inflation theory itself, which could have diluted their density to almost zero. They are phantoms of unified physics, lost magnetic poles of creation, perhaps forever hidden from us by the expansion of space. From hypothetical particles, let's return to real, but equally elusive, ones. Neutrinos are elementary particles that barely interact with anything. Trillions of them pass through your body every second without leaving a trace. For a long time, scientists believed they had no mass at all. but experiments revealed that neutrinos can oscillate, transforming from one type to another as they travel. This can only happen if they have a small but non-zero mass. That discovery was the first confirmed step beyond the standard model of particle physics, which predicted massless neutrinos. These ghostly travelers may hold the key to a deeper, hidden layer of nature's laws. Some of these ghosts once appeared to move faster than light. In 2011, the Opera collaboration announced that it had detected neutrinos arriving 60 nanoseconds earlier than expected in a beam sent from CERN to the Gran Sasso laboratory in Italy. The claim shook the world of physics. It seemed to violate the very foundation of relativity. But after months of scrutiny, the cause was found: a loose fiber optic cable. The episode became a cautionary tale about the importance of verifying sensational results, and how easily the pursuit of a miracle can lead us astray. Not all velocity anomalies turn out to be mistakes. Hypervelocity stars are real. Stars ejected from the centers of galaxies at speeds high enough to escape them entirely. They race through intergalactic space at millions of kilometers per hour. The most likely cause is the gravitational slingshot effect. When a binary star system ventures too close to a supermassive black hole, one star is captured while the other is hurled away with tremendous force. Each such star is a lonely exile, a cosmic wanderer cast out from its home to die alone in the cold depths between galaxies. Some stars don't flee, they come too close. A tidal disruption event occurs when a star passes within the fatal reach of a supermassive black hole, where tidal forces exceed the star's own gravity. The star is torn apart, stretched into a long stream of gas, spaghettified, before its remains spiral into the black hole, producing a powerful flash of light. These outbursts let astronomers study dormant black holes in distant galaxies that would otherwise remain invisible. It is a cruel but magnificent spectacle. The final scream of a dying star illuminating the dark with its last breath. The darkness at galactic centers sometimes glows with a different kind of light. Quasars are the brightest, most energetic objects in the universe, the blazing hearts of galaxies powered by supermassive black holes devouring matter. As gas and dust fall inward, they form an accretion disk heated to millions of degrees, shining thousands of times brighter than the galaxy around it. Some quasars are so distant that we see them as they were in the infant universe. They are beacons from the cosmic past, witnesses to the turbulent youth of galaxies and the hunger of their luminous hearts. A special kind of cosmic beacon points its light directly at us. A blazar is a quasar whose relativistic jet, a stream of plasma fired from the poles of a supermassive black hole at nearly the speed of light, happens to be aimed straight toward Earth. Because of this alignment, its radiation appears vastly amplified and highly variable. A blazar's brightness can change by several times in just a few hours, sometimes even minutes. Observing one is like staring down the barrel of a cosmic cannon, spewing particles of unimaginable energy. They are among the most extreme and mysterious natural particle accelerators in the universe, fiery fountains erupting from the deepest wells of space-time. Giants were born not only in galactic centers, but also on their outskirts. Globular clusters are dense, spherical gatherings of hundreds of thousands or even millions of ancient stars. For a long time, astronomers believed all stars in a given cluster formed at once, from a single gas cloud. But detailed observations reveal that many clusters contain multiple generations of stars with different chemical compositions. How such bursts of star formation occurred in these old, compact systems remains a puzzle. Perhaps these clusters are the fossil hearts of dwarf galaxies, devoured long ago, preserving the layered memory of their violent past. Some clusters behave even more strangely. Omega Centauri, the largest globular cluster in the Milky Way, is so massive and chemically diverse that many astronomers now believe it to be the stripped core of a former dwarf galaxy, consumed by the Milky Way billions of years ago. Its dense core may even conceal a black hole of intermediate mass, the elusive bridge between stellar mass and supermassive black holes. Omega Centauri is a ghost galaxy within our own, an eternal reminder of the cosmic feasts that shaped our home across deep time. The search for these elusive intermediate mass black holes, IMBHs, is one of the most active frontiers in astrophysics. They are thought to weigh between hundreds and hundreds of thousands of suns. Their existence is crucial to understanding how supermassive black holes form, yet finding them is extraordinarily difficult. They are too small to power bright galactic nuclei, and too large to arise from the death of a single star. Astronomers hunt for them in the centers of dense star clusters or by detecting tidal disruption flares when they tear apart passing stars. But so far, the evidence remains scarce. They are the missing middle class of black holes, the lost link in the chain of cosmic giants. Sometimes, mysteries hide not in the extreme, but in the ordinary. The faint young sun paradox refers to a puzzling contradiction. About 4 billion years ago, the sun should have shone 25 to 30% dimmer than it does today. At that brightness, Earth ought to have been a frozen ball of ice. Yet geological evidence shows liquid water and even early life existed. What kept our planet warm? Perhaps Earth's early atmosphere was far thicker and richer in greenhouse gases, such as methane. This mystery reminds us of the fragile balance that allowed life to emerge and survive in the glow of a cooling star. That balance can tip the other way, too. Hot Jupiters are gas giants roughly the size of Jupiter, or larger, that orbit their stars at blistering proximity, completing a revolution in just a few days. At such distances, their atmospheres reach temperatures of thousands of degrees. But how did they get there? They couldn't have formed so close to their stars. The leading theory suggests they were born far away and migrated inward, pulled by gravitational interactions with their disks or other planets. These worlds are proof of the wild diversity of planetary systems, true wandering giants lost to the heat of their suns. Some worlds are even stranger. The planet Osiris, or HD 209458b, is a hot Jupiter that is literally evaporating under the fierce radiation of its star. Observations show it has a vast tail of hydrogen gas, like a comet's, streaming away into space. The planet is melting before our eyes, losing millions of tons of atmosphere every second. Though it won't completely vanish during its star's lifetime, Osiris demonstrates the brutal extremes in which some worlds exist. A planet dying from its own sun's embrace, a vaporous ghost drifting into the void. Even suns can be strange. Przybylski's star, HD 101065, is a true chemical anomaly, a cosmic laboratory unlike anything else. Its spectrum reveals traces of short-lived radioactive elements such as promethium and even actinides like americium and einsteinium, which should have long since decayed. Where could they come from? One hypothesis suggests they might be the decay products of super-heavy elements from a theoretical island of stability. Przybylski's star is a stellar alchemist, a cauldron of impossible elements, challenging everything we thought we knew about nuclear fusion and the chemistry of the cosmos. The laws of nature can break down not only within stars or atoms, but across entire systems. The planetary system of pulsar PSR B257+12 was one of the first exoplanetary systems ever discovered, and it remains one of the strangest. It hosts at least 3 Earth-sized planets orbiting a neutron star, the dead remnant of a massive star that once exploded as a supernova. How could these worlds have survived the blast? Or did they form later, from the debris left behind? These pulsar planets are worlds born from ashes, circling a cosmic corpse, silent witnesses to death and impossible rebirth. Some worlds seem torn straight from the pages of science fiction. The so-called Diamond Planet, 55 Cancri E, is a super-Earth orbiting extremely close to its star. Models suggest it's rich in carbon, and under immense heat and pressure deep within, that carbon could crystallize into diamonds. As much as a third of the planet's mass may be solid diamond. Its surface is likely coated with graphite, beneath which lies a vast layer of gemstone, glittering in the dark. This world is a treasure we will never mine. A jewel adrift in the void, the dream of wealth made real on a planetary scale. from the sparkle of distant diamonds to the strange glow of our own world. The mysterious earthquake lights are rare flashes seen in the sky during or just before major seismic events, shimmering like distant lightning or auroras. Their origin is still uncertain. One theory holds that intense stress in rocks before a quake generates electric charges that ionize the air, producing the glow. These eerie lights are a haunting reminder that even our own planet harbors hidden energies, capable of illuminating the heavens at moments of greatest strain. Energy can take the form of sound as well. The hum, a low, persistent droning noise, has been reported in various places around the world, such as Taos, New Mexico, and Bristol, England. Only some people can hear it, and no instrument has ever pinpointed its source. Theories range from industrial machinery and infrasound to subtle geological effects, or even psychological origins. Whatever it is, this ghostly vibration blurs the line between the physical world and human perception, a quiet, stubborn whisper of the earth that only a few can hear. Perception itself shapes how we understand the cosmos. Olbers's paradox asks a deceptively simple question. If the universe is infinite and filled evenly with stars, why is the night sky dark? Wherever we look, our gaze should end on a star's surface. The answer lies in the fact that the universe is not infinitely old, and it's expanding. We don't see light from the most distant stars because it hasn't had time to reach us yet, and the expansion stretches that light, red-shifting it into darkness. The very blackness of the night sky is direct evidence of the Big Bang and the finite age of our world. Even within that darkness, strange motions lurk. The dark flow is a hypothesized large-scale motion of galaxy clusters drifting together in one direction, faster than known gravity should allow. Early WMAP satellite data suggested that hundreds of clusters were streaming at millions of kilometers per hour toward the constellations Centaurus and Hydra, as though pulled by something beyond the observable universe. Later studies questioned the result, but the idea endures, that unseen forces outside our cosmic horizon might still tug on our universe. It's a thrilling, unsettling thought, that something beyond the edge might still leave its mark within. External influence can also be more subtle. The libration anomaly of the moon refers to its gentle wobbling, slightly stronger than expected. These tiny but measurable shifts suggest that the moon's core might not be entirely solid as once thought, perhaps partly molten, with a thin layer of liquid between core and mantle. Such minute oscillations, detected by laser ranging, allow scientists to peer into the moon's hidden interior, revealing a quiet, lingering geological heartbeat beneath its still surface. Other faint companions may circle above our heads. The Kordylewski clouds are two hypothetical dust clouds orbiting Earth near the Lagrange points L4 and L5 of the Earth-Moon system. At these points, the gravity of Earth and Moon balances perfectly, allowing tiny particles to stay in stable orbits. These dust moons are extremely diffuse and faint, almost invisible from the ground. Only recently have convincing observations confirmed their existence. They are ghostly companions of our planet, two silent veils of cosmic dust following us in our endless dance around the sun. Hidden activity also stirs among the moons of other planets. Hyperion, one of Saturn's moons, spins in utter chaos. Its rotation axis tumbles unpredictably. Its days vary wildly, and its future orientation is unknowable. This behavior stems from its irregular shape and eccentric orbit, constantly torqued by Saturn's gravity. Hyperion's porous, sponge-like surface makes it look like a cosmic pumice stone, a symbol of chaos within the clockwork of the solar system, a reminder that not everything moves in perfect, graceful ellipses. Unpredictability may also exist in the very constants of physics. Some theories suggest that fundamental constants, such as the fine structure constant, may have been different in the past or may vary across the cosmos. Spectral studies of distant quasars have yielded conflicting results. Some hint at minute variations, others find none. If these constants truly change, the implications would be enormous, altering our understanding of physics and even the conditions for life itself. Perhaps the universe has gone through different settings of reality, and we just happen to live in one of its stable phases. This delicate fine-tuning of the universe is itself a mystery. Why are the fundamental constants precisely what they need to be for chemistry, stars, planets, and life to exist? If they were even slightly different, the cosmos would be unrecognizable, a dark, sterile expanse of hydrogen or chaos. This is the essence of the anthropic principle, either an incredible coincidence or evidence that we live in one of many universes, a lucky bubble in the vast sea of possibilities. It's one of the deepest questions physics has ever posed, about the nature of existence itself. Physics also hides smaller, sharper puzzles. The proton radius puzzle arose when two different measurement methods, using ordinary hydrogen and muonic hydrogen, where an electron is replaced by a muon, gave slightly different proton sizes. The discrepancy, about 4%, is small but statistically significant, defying experimental uncertainty. It could hint at an unknown interaction involving the muon, or a flaw in our understanding of quantum electrodynamics, or even a mismeasured fundamental constant. This tiny anomaly in one of nature's simplest particles may be a doorway to entirely new physics. New physics might also be needed to explain the behavior of entire galaxies. The Tully-Fisher relation links a spiral galaxy's luminosity to its rotation speed, an empirical law that works astonishingly well but isn't fully explained by current theories of gravity or dark matter. Some scientists see it as potential evidence for modified gravity theories, such as MOND, modified Newtonian dynamics, which proposes that gravity behaves differently at large scales. This simple correlation has become a battleground between standard cosmology and its challengers, a quiet debate about the very nature of attraction itself. A battle of ideas also rages around the origin of life itself. The Fermi paradox poses a haunting question. If the universe is so vast and ancient, filled with trillions of planets, why haven't we seen any sign of extraterrestrial civilizations? Where is everyone? Possible answers, the so-called great filters, range from grim, intelligent life is rare or self-destructive, to hopeful, they're hiding, or we simply haven't looked the right way. The very absence of contact is an anomaly, a silence so deep it roars. This great quiet of the cosmos is one of the most thrilling and unsettling mysteries of all, a question whispered to the stars that still awaits an answer. Perhaps the answer lies in the fact that life might exist in forms beyond our imagination. In theory, it could be based not on carbon, but on silicon, or use liquid methane or ammonia instead of water as a solvent. Such alien biochemistry might thrive on frozen moons like Titan, where methane rains and rivers carve an entirely different hydrological cycle. We search for reflections of ourselves, but the universe may be teeming with forms of existence so foreign we can't yet recognize them. The silence may not be the absence of life, but our inability to listen on the right frequency, a symptom of our Earth-centered view of the cosmos. Those frequencies we do detect sometimes behave strangely. Peritons were mysterious radio bursts that mimicked fast radio bursts, FRBs, but came from Earth itself. For years, they puzzled astronomers at Australia's Parkes Observatory, until the culprit was found. Microwave ovens in the staff kitchen opened before their timers finished. That simple act produced a short radio pulse. It's a funny but humbling reminder that we must rule out every earthly source before declaring a cosmic miracle, and that the greatest mysteries sometimes hide in the most ordinary places. But not all wonders turn out to be kitchen appliances. The exoplanet KIC 112557548b appears to be disintegrating before our eyes. It orbits so close to its star that its rocky surface is evaporating, forming a vast tail of dust trailing behind it like a comet. That dusty veil causes periodic dips in the star's brightness. We don't see the planet itself, only its shroud. It's a ghost world, a planet crumbling into dust, slowly vanishing in the light of its own sun, one of the harshest fates a world can endure. Dust in space can conceal, but it can also shine. Extended red emission is a mysterious glow observed in some nebulae and interstellar regions, a diffuse red light that can't be explained by ordinary fluorescence or scattering. One hypothesis suggests it comes from complex organic molecules or nanoparticles that absorb ultraviolet light and re-emit it as a red glow. This eerie luminescence may be the light of cosmic chemistry itself, the quiet blush of cold nebulae, perhaps a forerunner of life glowing softly in the void. The chemistry of the cosmos is full of surprises. In cold, rarefied interstellar clouds, astronomers have discovered complex organic molecules, alcohols, sugars, even precursors of amino acids. How such intricate compounds form in such extreme conditions remains uncertain. They may arise on the surfaces of icy dust grains, which act as natural catalysts. These clouds are true factories of organics, which may have seeded the young Earth with the building blocks of life via comets and asteroids. The universe is not sterile. It's alive with chemistry, waiting in the dark between stars. Sometimes that chemistry reveals itself through color. Uranus and Neptune, both ice giants of similar mass and composition, display markedly different hues. Uranus pale blue, Neptune deep azure. Why? Recent studies suggest the reason lies in a layer of methane haze in their atmospheres. Neptune's haze is thinner, letting us see deeper, bluer layers, while Uranus's thicker, whitish haze dilutes its color. This subtle difference in atmospheric dynamics produces a striking visual contrast between twin worlds, proof that even among similar planets, the devil hides in the details. Some differences are even more profound. The hexagon of Saturn, a colossal, perfectly shaped, six-sided pattern of clouds encircling the planet's north pole, is one of the most striking natural geometries in the solar system. Each side is longer than Earth's diameter. It rotates with the planet, staying fixed over its pole, not a solid structure but a standing wave in the atmosphere. Laboratory experiments have reproduced similar polygons, yet the precise conditions that created Saturn's perfect hexagon remain unknown. It is a harmony born of chaos, a symmetry painted by the wind. Order also manifests in motion. Saturn's rings, made of billions of icy and rocky particles, display transient spokes, faint radial streaks that appear and fade within hours. They don't rotate with the rings, but with the planet's magnetic field. Scientists believe these spokes are tiny dust grains levitating above the ring plane under electrostatic forces, casting delicate shadows. They are fleeting patterns drawn by magnetism's invisible hand, like shadows gliding across a giant cosmic record. And those majestic rings themselves, symbols of planetary beauty, hold their own mystery. For centuries, they were thought to be as old as the solar system itself. But data from the Cassini spacecraft suggest they may be surprisingly young, perhaps only 10 to 100 million years old. They're too clean and bright to have survived billions of years without darkening from meteoric dust. That means the dinosaurs may have looked up at a Saturn without rings. Perhaps they were born from the destruction of an icy moon, a recent event in cosmic terms. Their youth remains a quiet enigma, a reminder that even beauty can be fleeting. The record of the cosmos plays stranger music still. The chorus and whistler waves are natural radio emissions in Earth's magnetosphere. When charged particles from the solar wind collide with our magnetic field, they generate these low-frequency waves. Converted into sound, they resemble birdsong, whistles, or an ethereal choir. Astronauts in orbit have sometimes heard these ghostly tones, the song of Earth itself, sung in defense against the solar wind, a delicate soundtrack of our planet's dialogue with the stars. Interaction can also be far more destructive. The Carrington event of 1859 was the most powerful geomagnetic storm ever recorded. Triggered by a massive coronal mass ejection from the sun, it produced auroras so bright they were seen as far south as Cuba and Hawaii. Telegraph systems around the world failed, operators were shocked, and some lines continued transmitting even after being disconnected from power. If such an event occurred today, it could cripple global power grids and satellites, throwing our civilization back decades. It is a sleeping threat, dormant at the heart of our solar system. The sun holds many other, less dangerous but equally puzzling mysteries. The coronal heating problem remains one of the oldest enigmas in astrophysics. The sun's outer atmosphere, the corona, reaches millions of degrees, while its visible surface sits at only about 6,000 degrees Celsius. It seems backward. How can the atmosphere be hotter than the source beneath it? Leading theories point to magnetic waves or countless tiny nanoflares constantly erupting in the corona. We still don't know exactly what sustains this invisible fire, this blazing halo of mystery around our star. In pursuit of answers, we've come closer to the sun than ever before. NASA's Parker Solar Probe has discovered strange magnetic structures in the solar wind known as switchbacks. These sharp, S-shaped bends suddenly flip the direction of the magnetic field, and as the probe passes through them, the solar wind's speed spikes dramatically. Their origin is still uncertain, but they may be the key to understanding how the solar wind accelerates to supersonic speeds, and how the corona stays so hot. They are whirlpools in an invisible stream, carrying the star's breath outward into the deep. Our sun is not alone in its strangeness. Epsilon Aurigae is a baffling binary system, a bright supergiant paired with a mysterious, unseen companion surrounded by a vast disk of dust. Every 27 years, that disk passes in front of the supergiant, causing a deep eclipse that lasts nearly 2 years. The nature of the hidden object at its center remains unknown. It could be a single massive star or a tight pair of smaller ones. The system is a set of cosmic clockworks where a colossal cloud of dust acts as the hand of time, marking decades-long cycles across a human lifetime. Dust clouds can hide not only stars, but worlds in the making. In the PDS-70 system, astronomers captured the first ever image of a planet in the process of formation. Around the young star lies a vast protoplanetary disk with a clear gap, and within that gap orbits PDS-70b, a newborn planet still feeding on gas and dust. It's a glimpse of creation itself, a cosmic nursery, showing the process that gave birth to Earth billions of years ago. A new world, swaddled in the dust of its own making. Now imagine a family of 7 worlds, dancing in perfect rhythm around a faint, cool star. This is TRAPPIST-1, only 40 light-years away. 7 Earth-sized planets circle an ultra-cool dwarf, several within the habitable zone, where liquid water might exist. Their orbits form a precise chain of resonance. For every 8 orbits of the innermost planet, the next completes 5, then 3, then 2. It's a celestial symphony, evidence of a calm and graceful past migration. A music box of worlds, wound billions of years ago, each planet a note in the soft melody of time. But not all worlds are born beside their suns. There exist rogue planets, interstellar wanderers drifting alone through the dark, unbound to any star. They were likely ejected from their birth systems during early chaos. They emit no light and reflect little, making them nearly impossible to detect. Astronomers find them through gravitational microlensing, when one briefly amplifies a distant star's light as it drifts past. Our galaxy may be filled with these dark, lonely travelers, eternal orphans of the cosmos, sailing through endless night. Among these wanderers may drift far deadlier things, rogue black holes. Theories suggest that millions of them roam the Milky Way, born from massive stars that exploded asymmetrically, kicked into the void. Others may have been expelled from dense clusters, or even from the galactic core itself. Invisible unless they distort starlight or consume nearby gas, they are the silent predators of the night, unseen yet omnipresent, the most solitary and dangerous inhabitants of our galaxy. Some travelers may even carry life. The panspermia hypothesis proposes that life didn't originate on Earth but arrived from space, carried by meteorites or comets. Microbes hardy enough to survive extreme conditions could drift between planets or even stars, sheltered within asteroids. Though this theory doesn't explain life's ultimate beginning, it suggests that life might be a galactic phenomenon, spreading like seeds on the cosmic wind, waiting for fertile soil. That wind can be quite literal. Intergalactic winds are massive outflows of hot gas driven by active black holes or intense bursts of star formation. They blow gas out of galaxies, depriving them of the material needed to form new stars, thus regulating their growth. At the same time, these winds enrich the intergalactic medium with heavy elements forged in stars. They are the breath of galaxies, shaping their evolution and destiny over billions of years. And finally, the fate of the universe, the last and greatest anomaly. Depending on the nature of dark energy, several endings await. The Big Freeze envisions eternal expansion. Stars burn out, matter decays, and only cold and darkness remain. The Big Rip is more violent. Dark energy grows stronger, tearing apart galaxies, stars, planets, and eventually even atoms. The Big Crunch reverses the story, as gravity wins and the universe collapses back into fire. Our final destination lies hidden in the darkness, within equations we still only partly understand. Yet even that darkness may not be the end. In a universe of the Big Freeze, long after every star has died, events will still unfold. Black holes will evaporate slowly, over countless trillions of years. Perhaps new, unimaginable forms of life could arise, built on ultra-slow processes far beyond our comprehension. Time itself will lose meaning. It will be an era of patience, an eternity stretched thin, where the universe becomes its own final anomaly, a quiet miracle dissolved into infinity, the last breath of being. And so we reach the end of our silent journey through the strangest corners of the cosmos. We have seen voids and galactic walls, heard the whispers of dying stars and the silence louder than any sound. Every anomaly, every mystery, is not a flaw in creation's code, but part of its poetry. They remind us that the universe is not just a mechanism to be solved, but a living mystery, forever one step beyond our imagination. If you enjoyed this quiet voyage, consider liking, subscribing, or sharing your thoughts below. It helps other dreamers find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy, and let the gentle whispers of cosmic anomalies lull your thoughts to rest. Good night.